That's our intro song. All right, that's good enough. All right. Whew. Okay, so it's been a while. I apologize for being a little late in the start of this, but I'm glad you're all here. Thank you for joining me and my members of the labs team for our coverage of the AMD Threadripper 7000. It's kind of our review roundup.
Yeah, they're good.
Yeah. All right. Thanks for the show. All right. Hey, good job, everybody. Nice. Easy peasy. So cool. Yeah.
I can start off, get us going if you want.
Yes.
Just kind of get some discussion started.
Yeah. Well, I mean,
so just so
let's do little intros first, right? Just to make sure, in case anybody doesn't already know, as we do. We got Kelly Shipman, our 3D virtual production game dev expert person, and Matt Bach, our media and entertainment. He handles most of the Adobe suite. Yeah. Man, I got to get back into the flow of this thing.
I know it's been a while.
It has been. But I guess we'll just dive right into it. Yeah. So Matt, go ahead and get us rolling.
Sure. Yeah, I'll get us rolling here. So first of all, yeah, it's there were actually two launches technically. There's the Threadripper 7000 and then the Threadripper Pro WX. No, Threadripper Pro 7000 WX. So both of those, technically, the review embargo was yesterday. The actual full sales launch is today, so November 21st, if anyone's watching this on YouTube later. And so, yeah, both of those are technically launched right now. Ourselves and pretty much everyone else out there only has reviews up for the Threadripper because the Threadripper Pros are launched. And in fact, I believe we can even get like CPUs. The problem is motherboards are completely unavailable. Even for us, like, as you know, we're an AMD partner. We do a ton of work with them. We work with Asus and Gigabyte and ASRock and MSI and all those guys, and we have no board. So we can't. Yeah, so we can't even do testing for reviews or anything, let alone sell it in systems.
We can technically put the Pro CPUs in the other boards, but you lose all of the Pro features. So there's really no point to do that because you just end up with the regular CPU, but way more expensive.
Huh.
Yeah, pretty much. I mean, we might do the only exception to that is the Threadripper Pro CPUs do have a 96 core model, which isn't available on Threadripper. That technically it would work fine if you're doing like some of the stuff we'll be talking about later, where like if you're not memory bound, you don't need 4 GPUs. It's just pure CPU power. That could make it worthwhile. Now, that's a $10,000 CPU. Like MSRP is $10,000. So do you really care about saving a couple $100 on a motherboard or what is it like? It's like $500 or $600. So it's not nothing. But at that point, I'm almost like, oh man, just pay for the Pro board. Like, yeah, maybe you don't need any of that stuff, but you're already so far in. Like, you might as well. But we might still do that.
Yeah.
All right, we'll see. We'll see. So kind of our plan right now is we have most of our Threadripper content up. There's still a few things that we still want to do, but most of our Threadripper review and content is up. Threadripper Pro will have to just come whenever we get a board. We're hoping sometime like mid-December, but it's so hard to know. And and even then, like it takes us probably usually about 2 weeks to get through all of them. Because one of the problems is you have a single board then. We want to test stuff. Our product R&D team wants to test stuff for like what can we sell on our workstations. Right. So we both kind of have to coordinate that. And we have to test 4 different CPUs on it. The 24, 32, 64, and 96 core. And so each one of those usually takes about a day of testing. So that's 4 days alone plus an extra day because something will go wrong. And then we have to write everything and analyze everything. So it's probably going to take us like 2 weeks after that. So I'd be surprised if we have reviews ready to go before like January 1st, to be honest. But we'll see. We'll see.
Man. I feel like a lot of people don't realize just the kind of work that goes into benchmarking and stuff.
It's a lot.
Especially when we do workflow benchmarking that is a little bit slower than a lot of the simulated benchmarking. That's not the right word. lost my the word there I'm looking for. Synthetic benchmarking. There we go.
Oh, sure.
Because like those you can just do some operation for a few seconds and then time some things and be like, all right, it's this score. Whereas we're like, hey, I want to compile shaders in Unreal Engine. Well, that takes half an hour. Like it's just the way it is.
Yeah.
I want to compile the source code. It's gonna take a long time. It's the way it is. So yeah, for our stuff, it just takes longer because we're trying to do actual work.
Right. Right.
And we have to do it multiple times because especially when you get into real world workflows, there's sometimes odd things that people don't realize are in there. Like this is one of the things I deal with like Premiere Pro is they have a lot of optimizations built in, which are terrific for end users. But some of those optimizations like kick in at different times depending on like kind of what's going on in the background and things that wouldn't affect performance if we were doing synthetic. But it causes like priority of things to shift around. So we can't just do a single benchmark run. We have to do 2 or 3, or in some of the weird CPUs, sometimes when there's like a little bit of odd, like a number of logical processor groups and stuff like that, sometimes you have to do 3 or 4 or 5. Yeah, so that's why we basically give an entire day for each CPU is kind of where we're at right now. Like if we were actually working 24 hours, it probably wouldn't take that. But like one of our benchmark runs takes like 10. So it's like, yeah, we're not coming in at like, 9 p.m. to swap a CPU and hit go again. That's
No robot arms to help swap parts and stuff?
No. Our solution to that problem is just to have multiple test beds. It's cheaper just to buy multiple, motherboards and RAM and all that stuff. But that doesn't really work on launch day when we have one board. Or sometimes we'll have 2, but they're different brands, different models, so we can't really like run half the CPUs on that one and half on that one because different motherboards they throttle differently, they turbo differently. They're just too different, so we can't get away with that, unfortunately. Once that we have like supply, then sure we can build up 3 or 4 systems and then we can just have them.
Right. Want to get into the actual nitty gritty?
Sure, yeah.
Right.
I guess you can screen share if you want. Throw us over to the side. Okay, so I just cheated and I just brought up our review.
Yeah, there we go. I was going to say we might want to zoom in a little bit.
Yeah, that works pretty well.
Let's go.
So this is exactly what you can see if you're going on our site and you're looking for our Threadripper content creation review. All of our like content from perfect links in chat. All of our major content for big launches like this, we do a main article and then we actually split out by each of the different things we're testing. So like Lightroom Classic, Photoshop, After Effects. And in those, we dive quite a bit deeper. So if you want more than just surface level, you definitely want to read those individual articles. But those are really intended like, hey, I actually use Adobe Photoshop. That's all I care about. Yeah, then just read that one. But so in here, first of all, pricing wise, these actually aren't too bad. So versus the previous gen Threadripper Pros, so like this 64 core versus this new 64 core, it is a pretty decent price drop. So you can see even between the 64 core here and 64, it's a $1,500 price drop. So that's cool. So keep that in mind. This is also like it's DDR5. There's some frequency bumps. The big thing to kind of be aware of though is that the TDP is quite a bit higher. This is also, I believe this is the first time in quite a while that we're going to be using AIOs, all-in-one liquid coolers for a CPU like in our workstations. We're very historically traditional air coolers, heat sinks.
Yeah.
Typically less noise in most situations, less points of failure, simpler. But these things are they're really hot. So that is one thing to be aware of there is that you do have to invest in those bigger all-in-ones, which oftentimes aren't actually more expensive than like the Noctuas we use, but
right.
So yeah, price drop, which is terrific. It also means that like the 24 or the 32 core here is more in line with the previous generation 24 core. So when you're doing gen over gen comparisons, it isn't even really completely fair to do it on a core per core level. It really does make more sense sometimes to look at price. So keep that in mind.
Okay.
A bunch of stuff in here about test setup and blah, blah, blah. So I'll start here. I'll do a couple, and then maybe we'll skip over to Kelly's stuff, and then we'll end on my other stuff, just so I'm not
Sure.
talking myself forever. So the most boring ones I would say are Lightroom Classic and Photoshop, and I'll sit here on Photoshop, and that's really just because these aren't really the right applications for CPUs like Threadripper. That's not a issue with Threadripper. It's not an issue with like Intel Xeon. It's not really what they're made for. They're made for high core count, multi-threaded workloads. Photoshop and Lightroom Classic are not. So that's why you get like the 14900K is a fraction of the price and faster. Just what it is. Nice thing is that the new Threadrippers are faster than previous generation, and they're not too far behind like an Intel Core 14900K. So for the people who use Photoshop as like a secondary application, or this happens with like Lightroom Classic, like someone who does a lot of photogrammetry work, they might still use Lightroom Classic as a like asset management kind of thing, or to do some light editing, and then they throw it into photogrammetry stuff. So in that case, it's cool. It's great that it works okay. Yeah, it's not going to be as fast if that's all you care about. Yeah, you're not going to use one of these. But in the cases where it's like a secondary workload, they keep up. I guess that's the main thing. That's usually what we're looking at here is like, are they good enough? Or is there something weird like what you get with sometimes the Xeons where like, yeah, they start to have some like weird performance problems, or being aware that like the 64 core is actually going to be slower than the 32 and 24. So like it's helpful to know those things if you're going to be balancing between the two.
Okay. And that's probably because of that logical core business with Windows, right? You start getting into those really extreme high ends and it gets a little wonky.
Yeah. So what that is when you have more than 64 threads or 32 cores, Windows divides things up into two groups, and it treats it as if it was like a dual Xeon. Like it treats it as two physical separate CPUs. And so the issue you get is like if you're doing something on this CPU or this core, but memory is stored, or some of the data is stored in the memory that's on this other one, then it has to like kind of go across and then grab that data and then come back, and that adds extra latency. So if it's not really good at handling that, which a lot of lightly threaded applications like Photoshop, Lightroom, they really aren't. They're just not designed for these kind of CPUs. So it's just, yeah, it's not going to work really well. And that's one of the reasons why, especially in Lightroom, I'll come up to Lightroom, there are some weird things where like the 64 core Threadripper Pro from last generation was frankly terrible, like half the performance of a 14900K. And it's just because of that. So if we actually went into the BIOS and like disabled half the cores, this performance would shoot way up, like up here. So it's if you wanted to blame anything, it's not a blame AMD thing here. It's a technically blame Adobe, but it's more just like get the right thing, and then you won't have to deal with this more than anything else. With that, I'm gonna let Kelly talk for a little bit, so I'm gonna skip over some of the media and entertainment stuff, and we'll come back to it. Just because I'm talking way too much. Oh, scroll. There we go.
There we go. Using my first one.
Yeah.
All right. So Unreal, we also see some little peculiarities with this. You can see that the 64 core is actually the slowest of the new Threadrippers. Kind of ended up right there in the middle of the pack. I'm assuming that is this processor group problem. Not 100% sure on that, because we ran this, I don't remember how many times he ran it, but multiple times, and it got that same score all the time. But then when he, Evan, our person who does all the hardware swaps for us, was doing some like AIO and versus air cooler testing, he got one test where it was actually the fastest, but not every test. And so it was just inconsistent on what the results are. But the majority of the results were around this 450 seconds to compile the shaders. So
that would line up. I was just going to say that would line up with the logical process group thing, because Windows will randomly use kind of what cores it's going to use. And if you happen to use all of the cores on one of those groups, then it should be fine. But if one or two or some go to the other one,
Yeah.
then you might get this. So it might have just been that one run. It just happened that all of the cores were assigned in one group.
Yeah. Something was a little weird about it. And on the next slide for building lighting, you can see at the very bottom, the Intel Xeon 56 core had the same problem where that's now the slowest CPU in this test. And we had this problem before with the 56 core when we first tested that like I think also because it's a weird number of processor group, like it's not 32 cores, like it's not maxing out each group. It will get some weirdness because like now it's only using 20 cores or something, and because it takes that one group, maxes out the smaller group, but then the majority of the cores aren't doing anything or something like that. I don't know. But then here, the new Threadripper 64 core is the fastest, barely beating out the 32 core, but it is fastest. We can see like the next three numbers are the previous gen Threadripper Pro, and they're all about the same within that segment. So like this is a test where like going up in cores isn't necessarily improving things. Like there's a trade-off between it's going to be doing a bunch of multi-core things, a bunch of single core where it needs more clock speed, and then a bunch of IO writing and stuff like that. So what we're seeing here is probably just mostly the new jump to DDR5. And then I don't know if it shouldn't have any difference with writing speed to the drive because it should be all using the same drives. But that's why it's like these are all grouped together. The previous generations are grouped together. All of the Xeons are grouped together except for the 56 core that had some problem. And then the final slide on Unreal is source code compile. This one, everything worked out fine for all the different CPUs, and everything lines up where you'd expect, where Threadripper 64 core is the fastest, and then it just really goes down by cores if you don't count Xeon, where...
Yeah, that funny 56 core one just kind of snuck in there between.
Well, that's like in line with the rest of the Xeon CPUs. It's just Threadripper is that much faster. So yeah. There was a little peculiarity where the 36 core was slower than the 28 core Xeon. I don't know what's going on there. Again, it's just for Unreal Engine, a lot of cores does help, but I feel like going past 32 starts to get a little dicey if you're going to get any more benefit out of it. Like you can, and you might not. So I think the 32 core is like the sweet spot, and then
cool
64 core if you going to be doing some other stuff that might use multi-core, because a lot of times it goes hand in hand with rendering or servers or that kind of stuff where you'd need those cores anyways. So
okay,
yeah, Unreal Engine is a little finicky when it comes to a lot of cores. It wants them, but also it doesn't like them.
It's like, give me all you can, but then what do I do with all these cores?
Right. And that might just be a Windows problem. And if we could throw this all into Linux, but then that gives a bunch of other problems. So we can go on to rendering. Down to Cinebench is our first one. I really should just combine all these into one score for the webinar because they're all the same. But you can see here we actually see the real benefit to the new Threadripper Pro is that about, what did I say?
Like 35%.
Yeah, it was I have to go to the actual article. I don't want to jump there now. Yeah, it was like, it might have been 30-something% improvement over the previous generation. Probably largely due to the, what is that, 35?
It's 35, yeah.
Yeah, combination of core speeds, DDR5, that kind of stuff,
and the TDP too, power draw.
And TDP, it's just pushing a lot more into it. The real comparison is Threadripper 64 core versus Xeon 56 core. That's like a 75% difference. So for roughly the same price. I think the Threadripper is actually cheaper.
Yeah.
It
pretty sure.
Just 75% faster for less money than the Xeon. So it's just not even a comparison. I actually had a hard time writing the articles for rendering because the price to comparisons were just not even close. The only time that Xeon beat a Threadripper was the 56 core was faster than 24 core, which is a quarter of the price. So like, it's just night and day difference. I guess we could look at Cinebench single core just because it is kind of relevant. I view Cinebench single core as a synthetic because it doesn't have a real world. There's no one's rendering single core. Like it's just not something anyone does. But you do see how big of a jump there is from Threadripper Pro, which is down at the bottom, all the way up to now it's second place behind the 14900K. I think this puts it roughly on pace with the Ryzen 7000 series, maybe slightly behind
the regular desktop stuff. Yeah.
Yeah. So that's nice that like if you are doing 3D modeling and stuff like that, this does have pretty good single core performance. Not quite as good as the Intel, but you'll then get a lot better CPU rendering if you're doing V-Ray or Corona is the other really popular CPU renderer, or Autodesk Arnold, another one. And then we can go down to V-Ray and Blender, but they're the exact same as Cinebench. Like
which makes sense, right?
Pro is Threadripper Pro is way ahead of previous gen and light years ahead of Xeon for the same price.
It looks like in some of these, like Xeon does a little bit better. Like here, it's the 56 core is equal to the 32, so it's only half the cost.
Right.
And really, like you're saying, like this is really like where these kind of CPUs are super strong. Like, when you can like really do all this is also where I'm really interested in the 96 core, because I believe we do want to put out an article doing the 96 on the TRX 50 boards we had now, because again, like rendering, the memory channels won't matter, the PCIe lanes won't matter, so it should be pretty darn close to, even if you wanted to buy it on a pro board. But I mean, that should be like what, like here if the chart was extended, at least maybe living a little bit further. So it's going to be like twice the performance of the previous gen 64 core. And like, it's $10,000, but you know, that's not twice the cost of previous gen, is it?
I don't remember.
$10,000 versus 6,500. So no. So even from a like price to performance, that 96 core, when it makes sense, it probably will actually make sense. Like it'll be cheaper to do that than to buy two previous gen 64 cores. Maybe even make sense versus the current gen 64. Even though this is cheaper, like you got to remember, you got to buy two motherboards, and the motherboards are $1,500.
All that stuff.
RAM is expensive. Storage. Everything else. So that 96 core, I think a lot of people look at that price of 10 grand are like, oh man, that's stupid. No one's going to do that. But for the right workflows, man, it's going to be awesome.
Yeah. Anyone that, if you're buying this for like render nodes, CPU render nodes, like you can be like, yeah, sure, no problem. Give me, how many CPUs can you get into a node, or how many CPUs can you get per 10U of server space? And I'll take that. Actually, I think the problem we're having is with the Xeon, or the Epic version of this, is like cooling that.
Well, because people, like when they're doing nodes, they want it in like a 2U. So like it's got to be this thick, and they want to put a 350 watt CPU in it.
Well, the one we're looking at has 4 CPUs in a 2U.
Oh, cool.
Wow.
Okay.
Well,
so
I mean,
only 1,400 watts.
Yeah, and then 25,000 RPM fans and that kind of thing.
Yep.
Yeah.
Real quick, this is a little tangential question, but I just want to toss this out here. We have a question from Greg McKay on YouTube. They ask, my system has a Ryzen 9 3950X, 64 gigs of RAM, a 2080 Super graphics card. My main programming uses PixInsight, an astronomical image editing program. They go on to say that many of its processes use the CUDA part of the graphics card, so I was wondering if I should just upgrade the video card and if this could be a simple user swap.
Sounds like it would be like if it's using CUDA, then yeah, a new video card, especially from a 2080, like go up to a 4080, you're gonna have 4 times the performance roughly is what the math is on that. Assuming that that's what the program's using, and depending on who built your system, graphics cards usually are a very easy swap. You just need to check power.
Exactly. Yeah, because 2080S, I believe that's a single 8-pin, or maybe it's an 8 and a 6. But the new 4080s require 3 8-pins, isn't that right? Yeah. Isn't that what the adapter does? So you do need to check power. Make sure you've got the space, because those 40 series cards are thicker and usually bigger. So it depends on what size of power supply you need. You probably want, what does NVIDIA recommend? They probably minimum like 650 watt. I think in our systems we would probably do an 850.
Yeah.
But you could probably get away with a 650, but it might be kind of close. So,
Greg, if you got your system from us, definitely get in contact with support. They'd be able to give you a little idea about whether your current power supply is strong enough, if you've got all the right cables and things like that.
Yeah.
It looks like PixInsight also has a benchmark database that you can go look up, see other people's performance, and see what you would want to do.
So hopefully that means they have something that you can even run on your own system and then compare it to. I mean, that's what we always tell people with our stuff, because our benchmarks, we provide links to all of them. We're like, hey, you want to know how your system's going to compare? Just run it. Like, that's going to be way more accurate than any sort of like guesstimation that people are going to be making. Always better to just do it on your own system. Okay. Any other questions we wanted to tackle as they're coming in, or should we skip to my stuff?
Just a few comments about, I'm shocked AMD didn't go 6 and 12 channels on the RAM, that kind of thing.
Yeah, I don't think that's just necessary for most workstation kind of stuff. I
Yeah.
mean, everything in this article, we pretty much know, like, it doesn't really matter. 8-channel, 4-channel, DDR4. Well, DDR4 to DDR5 did make a little bit of a difference. But it's just most things are not as memory bandwidth limited as people think. A lot of people have a lot of perception of like, oh, you need all that bandwidth, but Adobe stuff, content creation things, usually not. If you're getting into some like specialized simulation stuff, maybe, but a lot of times at that level, you're working with like nodes or cloud space storage or cloud computing and stuff like that. Okay, so we'll skip over to the last bits of sections. So my stuff, so this is more the video side and like motion graphics, that kind of stuff. Actually, just a second. I realized I did not turn on the LEDs to my door because I work from home and I have kids. So LEDs are on now. Now they won't bother me. So After Effects is I would call it primarily a lightly threaded application, but it has bits and pieces that are moderately threaded. They added some new stuff about 2 years ago called multi-frame rendering that's adds a lot more multi-core capability, but it is not anywhere near to the level as something like rendering or code compiling. It goes from, it uses 1 core to now in very heavy things, it'll use more. It depends on how heavy that project is. So there's 2 results in here I kind of want to look at. The overall score is just kind of a mix of everything. So this is probably the best for most users. And even here, the new Threadrippers are terrific. The previous Threadripper Pros, they were a little bit behind the 14900K. And that caused just a little bit of awkwardness sometimes because people want the highest performance they can get, which would be the 14900K. But then at the same time, After Effects is an application where having more RAM can directly benefit performance in some cases because it stores data in RAM, and the more RAM you have, the more data it can store. And so like the less recycling it has to do, less like recalculating of individual frames it has to do. So if you have plenty of RAM, then it might be infinitely faster because you're not having to compute anything. So we had a lot of customers who would get the 4900K up to a certain level, and then when they need more than 128 gigs of RAM, they would go up to Threadripper Pro, but they would cost them a little bit of performance. With the new Threadrippers, you're no longer costing yourself anything, which is terrific. It's a slight performance bump, but I mean, it's like a minuscule amount. So you're not going to buy Threadripper just for the performance for most people. But hey, you're not having to give that up anymore. Now you can get, what do these CPUs support? A terabyte of RAM, technically, which is way more than anyone's going to need for After Effects.
For now. Yeah,
things are always getting bigger. But we do have some specific tests that are testing for very complex projects where that multi-frame rendering does come more into play. And there are plenty of people who do this kind of stuff, like very, very complex stuff. You hit play and it'll play at 2 FPS. You probably fall under this category.
What kind of project is that would be so robust?
Just very, very complicated things. Sometimes some of the things you see on like sports channels. So this test is actually a project that they put out to show off this feature. So in a lot of ways, it is like best case scenario. We actually know the person who made it. It was Kyle. I probably would butcher his last name. Kyle something. He does a lot of stuff in After Effects. He does a lot of teaching stuff, and he's the one to put it together. And we have a relationship with him. So we're like, hey, can we use this? And he was like, yeah, sure. Okay. Yeah. And so I would call this a best case. So like a lot of our stuff, you got to kind of consider where you fall between these two extremes because everybody's different. But if this is kind of where you're doing, you are hitting play and it's getting 2 FPS, you've got tons of pre-comps, tons of effects going on, you can actually benefit all the way up to the 64 core. So that's really cool. I mean, we're jumping from, we were at a score of like 300, now we're at 377, so that's what, a 20% performance bump or something like that. So like, yeah, it's not like game changing, but at the same time, that's just a single generation bump. Most people are upgrading only every other at the fast earliest,
right?
So it's going to be a lot more than that for what you'll actually be able to see. And then I have Premiere Pro and DaVinci
Threadripper, then.
Yeah, and actually, I have something I'll share after this. I'm working on an article of Threadripper for each generation and what current gen Threadripper compares. So I'll share that after I go through this, kind of the early stuff for that. So Premiere Pro and DaVinci Resolve are they're really interesting because like you might look at this and you're like, cool, there's no difference anywhere. Like it doesn't matter what you get. And there's kind of some truth there. The weird thing with Premiere Pro and DaVinci Resolve is the right hardware really depends on what you're doing within it. And it mostly comes down to what codecs. Because you have like long GOP codecs like H.264, HEVC. And for that stuff, the 14900K is terrific. I think we even have... Yeah, it doesn't really show well in these. But like the 14900K is really terrific because it has Intel QuickSync. It's actually better than even what our benchmarks often show because it's one of those situations where if you have it, it can be way faster if it's the type of media that only QuickSync supports hardware decoding of. So it's really hard to show in a benchmark because in a benchmark, we want to test lots of different things. And so you kind of have to look at those individual results. But so most people, they would go a 14900K in that situation. Something like Threadripper, those are really for people it's usually people working with raw footage. And in those kind of cases, I think that's this one. Yeah, raw footage, it can be a bit faster than like a 14900K. It's not game changing. We're talking like 10% or so. So it's not game changing. But if you work with like Red 8K, that 10% can actually grow to be more than that. Again, this is like averages over like 6 or 7 different tests. So just like the harder it is, the more Threadripper is going to benefit you. So that's kind of in the video space. It's more about what exactly are you doing in that application and then tuning exactly for that. But either way, the new Threadrippers are pretty darn good here. Again, with the price drop we were talking about at the very beginning, it makes them even better compared to like previous gen Threadripper, even though like the scores aren't that much higher, but it's a little bit more performance for lower cost. Like, how can you be not unhappy with that? And it pretty much exactly the same thing in DaVinci Resolve. DaVinci Resolve is a bit better at handling higher end hardware, so the scores are a bit higher. Things like raw, I think this is raw. Things like raw shows a little bit more of a benefit versus like a 1400K. I mean, 4900K here is way down here. So in this case, it's like getting up to 80% or so performance gain. So DaVinci Resolve just works a little bit differently. There are still some areas where like the 1400K is better. Like this is Fusion. This is basically DaVinci Resolve's version of After Effects. So motion graphics, VFX, that kind of stuff. Very lightly threaded, so 4900K will still be better for that. But most people just use Fusion for like 3D titles and lower thirds and stuff like that. So it's not too big of a deal. That's a bit slower still than like the 1400K. So yeah, that's all of my stuff. Overall, I forget what the exact amounts were, but I believe the average was something like in lightly threaded things, the new Threadrippers are like 10-15% faster than previous generation. And for very heavy threaded things, it's, what was the most you saw, Kelly? Like 45-50%?
Yeah, around there. For the 64 core, it's around that.
Yeah.
A little bit lower for the lower ones.
Yeah, which makes sense. And then versus Xeon, oh man, I feel bad for Intel. These things are just so much faster. I think the highest I saw was like where they were twice as fast. But
well, I mean, just looking at this chart here across the board, their base clocks are just faster. So it stands to reason that they would perform better. It's like, I mean, there's a little bit of competition in the boost clock column there, but I mean, how often is it holding the boost speed and for how long and things like that? It's, I mean, 2.2 gigahertz on the, what is that, the 3475X, the 36 core? That's crazy.
Yeah, base. Yeah, I mean, base is where base comes into play in my mind. So the easy math. Let me frame this a little bit better. So you do have these turbos, these max turbos, but also the more cores you're using, the lower the turbo goes. Right. And Intel and AMD, I don't believe they don't put that like on their spec pages. I think Intel might have it buried in some white papers that people sometimes they make public, sometimes they don't. So yeah, the more cores you do, the way I easily estimate it, which isn't perfect, but if you just want a rough estimate, the base clock is halfway in between the base clock and the turbo is typically around the all-core turbo. So in something like Cinebench or V-Ray, it'll actually be running, in this case, somewhere around 4 gigahertz probably. These new Threadrippers might be a little bit different because the wattage is way up. They might have been more aggressive, whatever. But okay, cool. You're going to be somewhere around 4. This one's going to be somewhere around, 3.5 or so?
Yeah.
Yeah. And they're a lot newer architecture. They're the Zen 4 stuff. So, like, yeah, they're both DDR5, but the new Threadripper stuff is, a newer architecture than the Xeon stuff. Because the new Xeons, I mean, who knows when we'll get the new Xeons, but hopefully when Intel does a refresh, maybe we'll see a jump. It's a big hurdle for them to come back to, though. Like, they're quite a ways behind right now.
Yeah, it'll be interesting to see how the HPC stuff pans out as well, because I know Xeon has in the past at least done pretty well, but I guess we'll see.
Yeah, and we do plan on testing that stuff. The Threadripper Pros will probably be our first one where we'll have not only a content creation review, but also a scientific computing review. It might not come out as early because we'll probably try to get one done and then switch over to do the other. But hopefully we'll have stuff for, HPCG and, I don't know, those aren't my space, but more of that scientific computing stuff, or like the AX512 bit of it comes more into play, things like that.
Yeah. Right on. Let's see. No other questions or anything coming through. What was that little last teaser bit you wanted to show?
Yeah,
Matt?
sure. Here, I'll even I'll stick it on my screen too, so we can go back to that. So this is an article I'm working on right now. So I'm hoping I can have this out maybe tomorrow. So it'll have a lot more detail in here. But basically, what I wanted to do is we totally realize that our articles, that when we're only doing the new product versus the competitor's product, so in this case Xeon, and versus previous gen, that doesn't always give people a good idea of like, well, my system is 3 years old. How does it compare? Unfortunately, we can't like retest every CPU for the last like 5 or 6 years every time, because that would just take forever.
Plus, your drawers are only so big. We can't keep all those CPUs in a drawer.
I think we actually do, but
Well,
but motherboards are a lot harder.
Yeah.
Oh yeah, some motherboards. Yeah.
But so what I wanted to do is I looked at everything that has like public databases. So our own Puget benchmarks. There's public databases that we can pull data from. V-Ray and Blender both have public databases. Cinebench doesn't. It'd be really nice if Cinebench did, because like every reviewer uses Cinebench. But so I looked at all that had public databases and tried to pull out, okay, well, what about the 3000 series? So Threadripper and Threadripper Pro 3000. What about the 2000? What about the 1000? And I only did it for the 32 core and the 64. And I just wanted to see, like, well, how much performance, if you have a second gen Threadripper, which I think someone in here said they had a second gen Threadripper, how much faster would these new CPUs be? So I am going to break it down by each one of those applications, but this is kind of the overall averages. So average performance gain across like everything, and then max, which is usually going to be like V-Ray or Blender. And it's pretty interesting. So the results are slightly different than what we show in our articles, just because I'm using public data. So some stuff might be overclocked, some stuff might be thermal throttling, who knows? I also didn't take into account like the GPU. So like for Premiere Pro, sure. I don't know what GPU was in there. Like if it was a first gen Threadripper, it probably had something like a 1080. But yeah, so
it's reasonable.
A lot of slop in here. But what's interesting is versus previous generation, this kind of lines up where we were saying the average was around a 25% performance gain. Max was up to about 50%. So like even gen over gen is terrific. If you go back to the 3000 series, you're looking at about a 50% performance gain on average, or up to a little bit more than twice the performance. So like that's pretty darn good. Like we're talking, what was that, 2 years ago, 3 years ago, something like that, 2 or 3 years ago, and you could get twice the performance. So cool. 2000, some of these like maxes go up, but that's in part because there was no 64 core back then. The highest was a 32 core. So the average was still more like 2.5 times faster with these new CPUs, or up to 4 times faster. Really cool. And then you go all the way back to first gen Threadripper. Those ones only went up to 16 cores, which is kind of funny now because like a 14700K is like 16 cores now. But that's anywhere from 3.5 times to, edging up on 7 times faster, obviously.
Faster? Wow.
I mean, your first gen Threadripper 16 core versus 7000 series 64 core. Like, again, there's some, like, it's not 100%
not fair, but still.
But, like, this was the fastest you could get back then. When Threadripper 1000 series was around and you were doing highly multi-core stuff, that was the best. And so like the best now is, you're probably looking at 7 times the performance. So I think this will still be really useful for people, just to give them a little bit of an idea. It doesn't help the people that are on like Ryzen or Intel Core or Xeon. But I'm also going to try to make it very clear that like, hey, everything in this, there's a public database, which means that there is a public benchmark that you can run. You know what's more accurate than this? Just run it on your own system. See what score you get, and then compare it, and then you'll know exactly how much faster a new system. There'll be nuances in there, and a benchmark is never going to be a perfect match for your own workflow, but it's going to be way more accurate than anything else. So I'm excited to get this up in the next couple of days, just because like some of these performance gains over 1,000 series. I need to put launch dates in here. Is the one thing I need to do.
Oh, there you go. That's smart. Yeah, you get a better idea of the timeline.
We're just looking at that because it looks like 2000 series was only 5 years ago. Like 5 years is not uncommon for people to hold on to a workstation.
Yeah, so, I was going to say that's a pretty common upgrade cycle right there.
Mm-hmm.
To get 4 times the performance. Wow.
Yeah, that's pretty good.
Wow.
That's pretty good. And that's just these Threadrippers. You know, when we get like the 96 core in there, that's probably a little bit too much of a compare. I mean, I might do this exact same thing for Threadripper Pro. Fun. And so like the max, I might need to divide it up by core count a little bit more because the max is going to be like, yeah, it's 8 times faster here. And this one's going to be like 10 times faster. I'm going to have to switch to a logarithmic scale or something.
Yeah, and then you need to look at the launch MSRPs because like the 2990WX was $1,800. Now that's what, the 24 core?
Yeah, I'm not going into that level of complexity. This is just to give people rough ideas. Hey, I mean, because then do we have to adjust for inflation?
Right.
Like, too? Like, yeah. But it's going to be a cool one. I'm looking forward to getting this up. This is also, I'm a bit excited about this because this is one of the few times I'm pulling from public databases and taking advantage of everything that's in our database. Because even for like our own benchmarks, we have something like 20,000 results in there. So like we should be able to pull some really interesting things here that doesn't cost us a lot of time. Like I'm going to be able to throw together this article in like 2 or 3 days versus if we actually had to test all of these, it'd be multiple weeks of getting things running and getting them updated and fixing this one motherboard we have for Threadripper 2000 that's probably broken. That's just been sitting in a drawer. I'm not looking forward to doing that.
Oh, looks like my video wigged out.
Oh no. We're losing Houston.
There we go. And you deal with technology, you get technical issues. Such is the way of technology. Awesome. I think that runs us through all of our results and stuff. Yeah.
Mm-hmm.
Right on. We'll leave the door open for a minute or two if anybody has any other questions. But otherwise, I think that's it, and that's all for today for this particular product launch. What's
Threadripper Pro hopefully will be in a month, maybe early January. It's hard to know exactly, but most of these workflows that we were looking at today, I don't think Threadripper Pro is going to really give you much of a benefit outside of rendering and code compiling with just the 96 core. The other ones, I don't know. I don't think there's going to be much of a benefit.
Yeah. Rendering may or may not, just because I don't know if the benchmarks as they're designed will sufficiently take advantage of those extra RAM channels or not, because they're so lightweight. But code compiling definitely will. Shader compiling definitely will.
Yeah, it'll be interesting to see. Because once we start getting into like pricing and stuff too, it's like, well, okay, do you get a 32 core Threadripper Pro or do you get a 64 core Threadripper that's only like $300 more expensive, but you get twice the cores? Is that going to give you more performance boost than the memory channels? So there's going to have to be a whole, I think we have planned a Threadripper versus Threadripper Pro and like break it down by like industry maybe and really try to get into that. Not just like CPU costs, but like, hey, now that we're actually selling all of these, we can actually pull out like the cost of our systems with our, normal markups and everything else built in. And we can hopefully do some of those pricing comparisons to help people, because I think it will cause a little bit of confusion about which one is actually best, given how different the pricing is.
Well, that'll be interesting.
The motherboards that we're currently looking at for Threadripper non-pro, do they have 8 memory sticks or 4?
I'm actually not sure.
Because I know in the past with like 3000, that was the last time there was a non-pro. Some of the boards on the market only had 4 sticks. Some had 8. So like some of that kind of stuff will make a difference too. Whereas if you're on Pro, you need 8. If you don't have 8, you're wasting the point of the Pro.
Yeah, let me check real quick because we
something
have
maybe-
the new CPU or the new motherboards or the new platforms are up. Like we're already selling them. It looks like 4 sticks.
Okay.
Yeah. So 4-channel, 4 sticks. Which I mean, you know, we can still do 256 gig sticks. I mean, they're expensive, but so you can still do a terabyte.
Yeah.
Yeah, it looks like we have 2 different boards. We have a gigabyte that we're using for ATX size systems, and then a Zeus that we're using for eATX larger systems. And both of those just have 4 memory slots. Difference there is primarily the PCIe slot layout and how many GPUs you can fit in there.
It made me think about it because that question earlier, my Chrome crashed when we were discussing it about the 12 channels. Why didn't they do that for this? On workstation motherboards, to get 12 channels, like that's so much physical space on a motherboard. Like it's ridiculous. It's rare enough to get 8 sticks onto a workstation class motherboard and still be an eATX even or SSI EUB. And get everything to fit.
Switch over to my screen real quick.
Sure.
So this is the WRX 80 we're using right now. So this is current gen Threadripper. New Threadripper boards though, like it won't really change all that much. And you can see like, it has 8 sticks, and then it has all the PCIe lanes. Like where are you going to put more sticks?
Jammed in there. Right.
Like it's already like these the chipset and VRMs and stuff have to have massive heat sinks in order to like handle the heat. So like you can't just like say, oh, we'll just take this out and put more sticks here.
Right.
Can't. And it has to be very close to the CPU just because of the bandwidth that's going across. Like you can't put RAM down here or anything like that. It has to be right there. Honestly, I don't even know how like server boards do it. I mean, I guess they use a lot of like GPU standoffs. So like the GPUs like go sideways and stuff. So like you're not actually stacking them direct. You're like stacking them on top of each other in weird ways. But yeah, I don't think we're gonna see 12 sticks on a consumer board unless someone does something crazy and like puts them on the back side of the board and like a special case that has like the motherboard is actually more in like the middle rather than like to the one side.
But really now that AMD finally brought back the non-pro version of Threadripper, they have 3 great segments where they have the non-pro, even if it only has 4 sticks. Most people could still do 512 gigs of RAM in that pretty easily, which is a lot. You have several PCIe lanes for a lot of these workstations. Then you can step up to Pro if you need that much RAM and that many PCIe lanes. And then you go up to Epic when you're like really have memory bound applications like AI and really high end server rendering or virtual machines or all that kind of stuff where you have massive core counts and massive RAM amounts and stuff. So it really makes sense to have a 4, 8, and 12 channels to just cover the bases of everything.
Nice.
Yeah. Plus, remember, we're already talking about like $1,500 motherboards for Threadripper Pro. Do you really want that to be $2,000? And remember, most people don't need that. Like even the things that are a bit like memory bound, like. Yeah, but you also need to have now 128 cores, and that's just you're just getting into a totally different class, and like you probably don't want that under your desk. Like it really should be in a server room. So like it's just it's just time for it to go into a closet somewhere with air conditioning and good power, and not just a random coat closet, please.
All right. Well, I think that brings us to the end. Thank you guys for taking time out of the day and joining us, and thanks to the audience as well for joining us. We're going to do this more regularly as different software, major software updates or product launches come out, things like that. So, follow the social media stuff, Twitter and Instagram and all that good jazz, or just swing by www.pugetsystems.com for all the articles, any specific stuff, performance testing results that we've published. So, thanks.